Hello again, this is John Modlin, Senior Systems Engineer for Pvt.Ltd in North America. So I just uploaded and rendered a video to YouTube, and I want to look and see how is the performance of that upload when I use my IOTA, a network capture visibility sensor that Pvt.Ltd makes to analyze that performance. So right here on this screen is the actual location in the traffic, in the time frame on here, the last 4 hours that I did that transfer. So I'm going to zoom in on that transfer here. And there it is. You can see, 35 meg spikes here. And I just want to look at one of them for now because I don't want to look at a whole gig of traffic. So there's one, and I can see the traffic is going from this particular device to this server here. So I'm going to remember this server here, and I'm going to go look at my server latency dashboard. And I'm going to go find that IP address in here just by selecting it right out of the list of available IPs that the IOTA has recognized in the traffic in that time frame. So I'm looking for 172.217.8.170, and there it is. And here is my file transfer. When I look at that, I see I've got, wow, really good latency here, 30 milliseconds. I mean, that's great for, especially considering it's pushing stuff out on the internet. And my IRTT is also low, the short-term round-trip latency calculated based on three-way handshakes. So the IOTA is telling me you had a great transfer here. You were, low milliseconds here in traffic all the way across the board here. So how can I verify this? So I'm going to pull up Wireshark here, and I downloaded that capture file into Wireshark directly from the IOTA here. And here I can see my 172.217.8.170 IP address talking to that device. And when I go up here to take a look at that stream, what I get is this graph here. This is a time sequence TCP trace graph in Wireshark. And a perfect transfer is considered to be from the bottom left to the top right. Now you can see 25 meg transferred in 25 seconds, indicating a 1 meg buffer. And that's about right for rendering video up through YouTube, and it's probably the default setting for most things, frankly, for rendering up to the internet. So there's actually two lines on here, and you can't see one of them because they're literally on top of each other. And the reason that is the second line that you can't see here is the lag time between the acknowledgments from the data being sent from the remote computer back to the sending computer. And the lag time is so small here, there's so little lag time, that the lines are right on top of each other. This is considered to be, for all practical purposes, a perfect file transfer. So Wireshark is telling us that's a really good transfer. And I don't have any reason to believe otherwise. It did transfer pretty nicely, and the IOTA is telling me the same thing. So did I really need to go to Wireshark to prove that? No, I could have just used my IOTA and the server latency dashboard, knowing the interesting IP address, to go find that traffic and have the IOTA calculate it for me for the latency values. This was a good transfer.